Hello, my mathematicians. This is Miss Foster with Math in Focus, 4th grade, Chapter 5, Lesson 6, Solving Real-World Problems with Data and Probability. We're going to divide this video up into two parts, one focused on data and one focused on probability. In our first problem, we'll be using the mean to find out the total amounts. In this problem, Mr. Seiko bought chicken, fish, and shrimp at a market. The mean weight of the three items was 7 pounds, and this is what I am showing in this bar model. He bought 3 different kinds of protein, and the average was 7 pounds each. The weight of the chicken was 8 pounds, and the weight of the fish was 4 pounds. What was the weight of the shrimp that Mr. Seiko bought? Well, using the mean to find the total means that I would take each of these amounts, these mean amounts of weight for each kind of protein. In this case, we have 3 different kinds of protein, and the mean is 7. And if I multiply them, I will get to the total weight. 3 times 7 is 21. And so now I know that each of these bars is equal to 21 pounds. Now that I know the total is 21, I need to reread the problem to find out how much actual chicken and fish were bought. Well, we read over here that the weight of the chicken was 8 pounds, so it's a little more than it was in the average. I'll put 8 here for chicken. And we find that the weight of the fish was 4 pounds. A lot less. So, if I add these two together and then take it away from 21, will I find out how much shrimp we have? Let's see. 8 plus 4 equals 12 pounds of chicken and fish total. 21 minus 12 will leave us with just the shrimp. So let's take away those 12 right there, and we will discover that 21 minus 12 equals 9. So Mr. Seiko bought 9 pounds of shrimp. Now let's practice using a line plot to find other data landmarks like median, mode, and range. A farmer weighed and recorded his crop of pumpkins to the nearest pound as shown in the line plot. So if we look at the title, we find that the weight of the pumpkins in pounds is what these numbers are showing us. Each X here then stands for 1 pumpkin. So what is the mode of this set of data? So the weight that was the most popular here definitely was 4. That's the weight of the pumpkins that showed up the most. What is the median of the set of data? Well, that is the X that falls right in the middle. So first of all, we're going to count up our X's. 2 plus 2 is 4. 4 plus 4 is 8. 8 plus 1, 2, 3, 4, 5 will be 13. 13 and 3 equals 16. 16 and 2 is 18. And 18 plus 1 is 19. So we have 19 pumpkins here. To find the halfway point, we need to go to the nearest lower even number to 19, and that would be 18. 18 divided by 2 is 9. So 9 on this side and 9 on the other side gets us to 18, and the one in the middle will be the median because 18 plus 1 is 19. So I'm going to count 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There is all of these then equal 9 of them, and all of these over here should be the other 9. Let me check. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that means that this amount is our median, which happens to be 4 again. Our last question asks us to use the data in a different way. It says here that the farmer sold the 4-pound pumpkins at $6 each, the 5-pound pumpkins at $8 each, and the 6-pound pumpkins at $10 each. He kept the rest of them. How much money did he earn from the sale? Well, let's see. That means he had 5 pumpkins at $6 each, 3 pumpkins at $8 each, and 2 pumpkins at $10 each. Pause the video and find out how much he earned for each of these colored bars. Check your multiplication with mine and see if you got the totals for each size of pumpkin and the money he earned from those. To find the total money he earned from the sale, we're going to have to add these together. So take a moment, pause the video, and add those together now. He earned a total of $74 from his pumpkin sale. Our final example of solving problems involving data has to do with using a stem and leaf plot. I'll remind you that the stem is the tens place and the leaves place is for the single ones. So we're using place value to organize our data. The stem and leaf plot shows the length of 8 ribbons in inches. The title here tells us the length of ribbons and the amount we're measuring by, inches. And at the bottom, just as a reminder, there's a little code. So we know that if there's a 2 on this side and a 6 on the other side of the vertical line, that equals 26. Let's try solving some problems with it. Our first question is, what length is the outlier? This is a term we have talked about in class, but I did not talk about it in the video I made about stem and leaf plots. An outlier is a data point that is unusual for the data set. Usually it's way, way bigger or way, way smaller. And so we want to pay attention to those because to understand the entire group of numbers, that particular data point may not really help us. What is the data point that is unusual for the data set? Well, I noticed there's a cluster of data points in the 20s and 30s. And then it jumps from 39 to 43. 43 isn't that far away from this cluster of data points right here. But 53 is a whole nother 10 inches. I think in that case, 53 is the outlier here. We also need to find the stem which has only even number in its leaves column. Well, let's see. The stem 2 for 20 has 6 and 8. The stem 3 has 5, so that's not all even. 3 is not even, and another 3 is not even. So I would say that the stem is 2 for the 20s. Then it asks us to change some data to make the mode 26 without changing the sum of the lengths. Pause the video for a moment and think it out for yourself. So if you want to keep the sums the same, you're going to have to trade around some numbers. I'm not going to add these all up, but I'm going to see which data point can I trade for another to make the mode 26. Well, right now the mode is 36. 30 and 6 here, 30 and 6 here. What if I traded this 6 and this 8? That would mean I wouldn't have a different sum if I added up all of these ribbon lengths. Instead, what I would have is 26 here and 28 or 38 right here. Hey friends, thanks for solving problems involving data. I love solving problems with you. Bye-bye for now.